Hello everyone, I'm Aamer. Welcome to a new video. In this video, we will start with a new algorithm of machine learning. So the name of algorithm is Logistic Regression. With one simple example, I will be explaining you this. For example, if I have table in which I have age, that is my X value, and medicine, that is my Y value. Fine. I have ages from 10 to 80, total 8 entries I have, and I'm just checking whether that age group person will buy the medicine or not. So on my y-axis, if you see, I just have two values, whether that person will buy or not. If buy, that is 1. If not buy, that is what? 0. So these are my two possibilities on my y-axis. On x-axis, that is my age, I have from 10 to 80. Fine. So according to the data that I have, the person from 10 to 40 will not buy medicine. Fine. That's the example that we are taking just for understanding this logistic regression. And from 50 to 80 group people will buy the medicine. That what the data says. So I just have plot that into my XY plane. Now compare this with linear regression. We have seen linear regression algorithm. Into that, all the examples that we have taken there, what was it? Their y values was continuous value. There were a lot of y values, right? And based on it, we have drawn a line which is at minimum distance from all the point. That was the concept of linear regression. Now into this logistic regression, if you see, we don't have continuous value of y. We just have like either 0 or 1. That is my y values, right? So if you see this and compare what I have like told you about supervised learning, there are two things: regression and classification. This doesn't seems to be of this doesn't seems to be of what? Regression, right? Of course, this is not of regression. This is of what? Classification only. Now you will be getting confused between these two, right? We are saying logistic regression and we are talking about classification. Yes, logistic regression algorithm is of classification, not of regression. We do have that word regression. We'll understand why that word is there. We'll also understand why we have that logistic word. Fine. So before we move on and understand, we implement those things. First, let's apply linear regression onto this data. We have equation of line as what? Y equals to, I'm going with b0 plus b1. X, for example, right? You can go with any equation, y equals to mx plus c, y equals to beta 0 plus beta 1 x, whatever you're comfortable with. Fine. I'm going with this equation. So according to the equation, remember how to find slope, how to find c. We have seen that into linear regression. And after finding the value of m and c, and if I draw a line for this data set, it will look something like this. It's not perfect that I'm drawing, but similar to this. Fine. That will be my equation of line for this data set according to what? Linear regression. So can we solve this using linear regression? That's what we are saying. If you see, according to this line, if I'm finding the probability at the age for example 25, so 25 value will be somewhere here, right? For 35, the value will be somewhere here. The value will be in between 0 and 1. Agree what I'm saying? It will be in between what? 0 and 1. For example, for 35, the value is somewhere here, so it will be 0.3 or 0.4. So that's what we will be getting. So based on that 0.3, 0.4 or 0.7, 0.8, whatever the value that you are getting between 0 and 1, will you be able to decide whether that particular age group person, the person with particular age, will buy the medicine or not? You won't be able to, right? You are not getting a perfect value. You are not able to decide whether that value is 0 or 1. Whether that, if it's 0 means what? That person won't buy. If it's 1, that person will buy it. But 0.4 doesn't mean anything. 0.7 doesn't mean anything, right? So there is nothing like maybe. Let me be very clear. Maybe रहता तो we won't have applied this, right? Maybe तो मुझे भी पता है कि वो हो सकता है कि buy करेगा या नहीं करेगा. We are applying this algorithm to get final answer whether that person will buy it or not. Fine. So what modification we can do is, we have something in between, that is 0.5 for example. I have 0.5 in between. So my 0.5 will be somewhere here. Let me be very clear. This is my no, fine, on y-axis, and this is my yes on y-axis. So what we'll be doing, any value that is above 0.5, we will say that is 1. Any value that is below 0.5, we will say that is what? No, fine. So this is the first thing that we will do. Means what? We are working on probability. Agree? If the probability is above 0.5, the answer is 1, that is yes. If it's less than 0.5, that is finally no. Now when we are doing it using linear regression, and we can see that we are getting the answer out of it, so why we need to go with a new algorithm then? It's working fine, right? So for this example, it's working fine. If I make changes into it, now see, if I have some points here also, fine, and for this example, of course, there won't be a point into negative. We won't be having any age into negative, right? And above this also, there won't be any value. There won't be any much value. Fine. Above 80, there will be very less person. But for example, for some other example, if you're taking, and we have some value after 0 here and some value here also. Fine. So for this values also, if you see, and few values here, this will be 1 1 1 for example, and this will be 0 0 0. Fine. So we have this much of access now. So for that, if I go with linear regression, this won't be the line. Line will be changed. Line will be somewhat more horizontal. We'll be having a line something like this. Now the 0.5 value will be changed for it, and the prediction will be raw. Getting what I'm saying? So linear regression won't work for all the values all the time in such cases. That's why we have something called logistic regression. And the first thing we have already talked about it, it will work on probability, right? We will be getting these values, of course, 0.5, and if the value of the probability is more than 0.5, we will decide that is yes, and if it's less than 0.5, we will say that's what that comes under no category. So logistic regression will be using this equation of line only. That's why we have that term regression. It works just like linear regression. It will be using this concept only. But of course, as we see, we have to modify something here, right? We have talked about probability here, and when you talk about probability has to be in between 0 and 1. Do you agree with me? It cannot go below 0, it cannot go beyond 1. So it's a line. Into linear regression, we have talked about it's a line, so it will go below this also, beyond this also, right? So we have to cut this. We don't have to take these things. It should not go like it has to be in between 1 and 0 only. To make this, the first thing that we will be doing is how to remove this negative part. So to remove negative part, if you remember, we will use exponential function. What's exponential says? If I say e raised to y, if you're using for any value of y, e raised to y, if you're using, it will be always positive. E raised to anything cannot be negative anytime. Do you agree with this? I hope you're getting this. E raised to y will always be what? Positive value, whatever is the value of y be. That's the first thing that we have done. Why we have done it? We don't want any negative value to be there. That's why we have modified, we have used what the exponential form of it, right? That's the first thing that we have done. The second thing, we got all positive values now, right? We have at positive term, we will be having the things. Now we don't want things to be beyond 1. How to do that thing? We don't want anything to be beyond. We got all positive, but we want what? Everything in between 0 and 1 only. So we don't want anything to go beyond 1. So for that, if you see, for example, if I'm taking the value of e of y as 5, so by what we can ensure that the value of 5 should come under 1? We have to divide it by a value which is greater than 5. Do you agree with me? We have to divide. For example, if I have 20 here, I have to divide 20 by a number which should be greater than 20. Then only I will be getting a value less than 1. Fine. So what is the best value that you can have? We can have 21. Just one more than it, right? If you have 5, you will divide by 6. If you have 19, you will be divided by 20. Likewise, If we have e raised to y in general term, how can we write? We will simply write e raised to y divided by e raised to y plus 1. Whatever is the value of e of y, we will just divide it by e raised to y plus 1. This will make sure we got this e raised to y. Let me write it here. E raised to y divided by e raised to y plus 1, dividing it by a number just greater than the e raised to y will give me what? It will make sure that I am not going beyond what? The value plus 1. So e raised to y made sure that it has to be positive value, and like e raised to y divided by e raised to y plus 1 will make sure that it won't go beyond the plus 1 value. I hope you got this right. Okay, moving on. So we were talking about the probability. For example, this is my probability of event happening. Means what? In this case, yes, probability of being yes. So P of yes is equals to e raised to y divided by e raised to y plus 1. If we just simply divide it by e raised to y, the complete equation, numerator and denominator, so P becomes what? P becomes, see, e raised to y divided by e raised to y divided by e raised to y divided by e raised to y plus 1 upon e raised to y. Simplify this equation, we will get 1 e raised to y divided by e raised to 1, that will be 1. Here it will be 1 plus, this is 1 upon e raised to y. Can I write it as e raised to minus y? Yes, you can write that as what? 1 upon 1 plus e raised to minus y. So this is one equation of logistic regression. Getting this? Now that is for yes, we said. For example, I am taking Q for the event not happening, means for no I am taking Q. So what? How can you write Q in terms of P? We can simply write in terms of P like 1 minus P is what? Q. Do you agree with this? Let me simplify this Q. 1 minus, just put the value of P here, that is 1 upon 1 plus e raised to minus y. So simplify this, you will be getting what? 1 upon 1 plus e raised to y. That's for Q, event not happening. Fine. So let's check the odds of this. Odd in this case will be what? Tell me. Odd of success divided by odd of probability of success or yes divided by probability of no. Right. Q is my no and P is what? My yes. So odd will be what? P of yes divided by, that is Q, yes divided by no, probability of yes divided by probability of no. So simply put these values. I have Q here and P here. So if you just write here the value of P and the value of Q, we will simply get e raised to y as the answer. So we can write P divided by 1 minus P, that is what? P divided by Q equal to e raised to y. Agree? If we take log on both the side, log of P divided by 1 minus P will be equal to log of e raised to y. If you know log of e, this will be what? Y log e. Y log e. Log e is 1. So we will get this equation finally, right? And if you remember the equation of line that we have written, it was what? Y equals to b0 plus b1 x. Fine. So if you substitute the value of y into this equation, we can simply say, because of these two equations, the b0 plus b1 x is what? Equals to log of p upon 1 minus p. So this equation is called as logit function. Fine. We are using logarithmic form of it, so that's why it is called as what? Logit function also, right? And that's why we have that name logistic. Getting it? So if you simplify it, we can say log of p upon 1 minus p is basically what? The equation of line. If you compare with the equation of line, that's b0 plus b1x. Fine. And using this, if you draw the like for our data set, if you draw the line, it will look something like this. Here it's towards negative infinity, here it's towards positive infinity. It's not perfect diagram, but this diagram is called as sigmoid. The name of this curve is what? Sigmoid curve. Clear? So this is the equation of sigmoid curve. Your logistic regression uses the sigmoid function to draw that line. I hope this explanation is clear to you. This is all about logistic regression.